Okay, so today we are going to begin chapter 3. Now, up here on the board, it's not in your textbook. However, these are 5 rules that you could always use to solve any equation. And these rules here, these 5 rules, could be used for the adding and subtracting, the multiplying and the dividing, even when they get a little bit more complicated and maybe we have to do some distributive property or just a little bit more work. So, rules for solving equations, and we're going to see these in action, how you can apply them to the problems we're going to do today. So, step number 1, you should always get rid of any parentheses. Distribute anything that needs to be distributed. Then the next thing you should do is to get rid of fractions by multiplying every term by the least common denominator. Then, before we even begin to try to solve, we need to combine all like terms on either the left side or the right side of the equal sign. So if there's any like terms, combine them with the signs that they have in front or in between them. Then the next step is to isolate the variable by getting the variable to be on one side, either the left or the right, all by itself by using inverse operations. Then the last step will be to divide both sides of the equal sign by the number that's in front of the variable. So these would be the 5 steps that you could apply to any problem, whether it's just a simple one step or if it's going to have multi-steps. So 3.1 is transforming equations by using addition or subtraction. So what we are going to be applying are the addition and the subtraction properties of equality. Now, keep in mind that when we apply these properties of equality, whatever you do to the left side, you must also do to the right side. So when you are doing your homework tonight, you must show the work, okay? And you must show that you're applying these properties. So the addition property of equality basically says that if you have an equation, x, let's say it's x minus 2 equals 5. Now, I already know you can do this in your head, but I want to see that you know how to apply this addition property of equality by adding the same number to the left side and to the right side. That will help to isolate the variable, and then I get x equals 7. Now, remember, whenever you're solving any of these equations, you can always take your answer and you can plug it back into the variable. If it does not give you a true statement, so if 7 minus 2 did not equal 5, then you know you've done something wrong and you should go back and rework your problem. So you can always take your answer, replace the variable with its value, and then solve it. Another example. Here is another one, and we're going to apply the addition property of equality. You must show this work. Add 8, it cancels from the left, and we get x equals 17 plus 8, and I get 25. Again, remember, you can check your answer by taking what you got, taking the place of the variable out, subtracting that, and see if it equals 17, which was your original equation. It did, and our solution is x equals 25. Now, you may see answers written as x equals whatever the value is, or you will also see them in the set brackets. I would accept your answer either way. Okay, our next problem, it's written backwards, but now we're going to apply our subtraction property of equality. Now, notice there's a negative number out front. However, notice what we need to do to isolate the n and get n all by itself is the 13 is being added to it. So to solve for n, I'm going to subtract 13. Here's where your rules of integers are going to come into play. you're doing -5 minus 13, which gives me a -18. And again, we can do our check. Plug it in. If when I add -18 plus 13, if it doesn't give me -5, I know I've done something wrong. However, it does work, so it's checked. Take a look what else we got here. So again, when we are transforming an equation by addition or subtracting, we're either adding the same number to both sides or we're subtracting to solve these. So let's see, we have one other example here in the written exercises. Now, when you're doing your homework tonight, you're not doing the oral exercises, you're going to do the written exercises. So what we're going to do here for the written exercises for your homework, and I'm going to do that sample right there in the middle, you're going to be doing 2 through 60 even. Okay, only the written exercises. So let me show you one more example here for the adding and subtracting before we move on to multiplication and division. So here, notice we've got a sample here, and this one's a little different, but it's still, we're going to try to isolate x. So I'm going to subtract 7. And notice here I get -x equals -5. Now, I can never ever have a negative variable. So I'm going to put a 1 here. I now need to divide both sides by -1. And I get x equals +5. Now, the other way you can think about this is you have a -x over here and a -5. Whatever you're going to do to the left, you're going to do to the right. So you could think of it as I'm going to multiply it by -1. Either way, you would make them both positive. So just be careful. You can never, ever have a negative variable. Okay, so the problem solving down here after the written exercises, we will talk about the problems or the word problems tomorrow. You will have those for homework. So if you want to try the word problems tonight, you can. They're the same thing we've been doing. The only difference is now is we don't have a domain. So you're still writing an equation and solving it. We just don't have a domain to work with. So I am going to assign the problem solving from 3.1 and 3.2 in addition to 3.3's homework tomorrow. Okay, so the problem solving still, and that'll be homework tomorrow night. Okay, so 3.2, this is where we're going to learn about the multiplication and the division property of equality. So again, we need to show the work. We need to keep things balanced. So if we're applying the multiplication property of equality, that's when we're going to be multiplying both sides of the equation by the same number. And when we apply the division property of equality, we would be dividing by the same number. So let's try some examples. So notice here on example 1, I have a multiplication equation. And the opposite of multiplication is going to be division. So I'm going to be dividing both sides of my equation by the number that's next to the variable. So to solve this equation, I am going to show that I'm dividing both sides by 6. Now, remember when we added and subtracting, we were trying to make it become a 0. But notice on this problem, 6 divided by 6 is 1. So technically it cancels, but really this is a 1x that remains. And then I actually have to do the division over here. And I'm going to divide 6 by 222. And 6 will go in here 3 times. And then I will subtract. And then it goes into 42 7 times. So x equals 37. Yes?
Can we do it as a fraction? Divide as a fraction?
Okay. You can leave it like so. If it goes in evenly, I want to see you simplify it to a whole number or an integer. However, if this were, if it didn't go in evenly, you could make it a mixed number or even leave it improper. However, if you leave it as 222 over 6, I would take points off for not simplifying. Okay, so you could actually simplify this to 37 over 1, but whenever you have a 1 in the denominator, I'm going to expect you to make it 37. Everybody with me on that? So again, you can do the check, and you can take your answer. We're going to substitute the number we got for x, and we're going to multiply that. If 6 times 37 does not give me 222, then I know I've done something wrong, and I need to go back and I need to rework the problem. However, it does give me 222. It checks, so I do have the correct answer, and it's x equals 37. Now, here's our next problem. Now, technically, and I remember those rules I showed you at the beginning? We're going to apply rule number 2, and we're going to clear the fraction. And the way that we clear the fraction is we're going to multiply both sides by the denominator. Now, technically, we could also divide by negative 2/3, which really means multiply by the reciprocal. But I'm going to show you how we could solve this by clearing the fraction first. So if I take my answer, my question, 8 equals negative 2 over 3t, and I multiply both sides by the denominator, I now get 24 is equal to negative 2t. Now I have a multiplication equation that I can divide both sides by negative 2 and get negative 12 equals t. And I can flip it around and I can show that t equals negative 12. Now, I'll show you the other way. If you're more comfortable doing it that way, where you're going to take 8, I'm going to rewrite the problem. And instead, if you want to show that you're dividing by negative 2/3, then you have to remember that you're doing 8 over 1 divided by negative 2/3, keep change flip, and flip this to the reciprocal, and now multiply those fractions. So I think it makes it a little bit easier if you clear the denominator first. This cancels, and then it gives you something a little simpler. And then we still get the same answer either way. Another way that I also do this is I take the reciprocal and I write it right next to it. So either way on these division ones when there's a fraction, yes.
Isn't it positive 2/3 because you're doing the opposite?
Okay, we're not making opposite sign, we're just flipping upside down. Okay, so whenever you're dividing fractions, we're not making signs different, we're just flipping upside down. Okay, so this is where the keep change flip, but the keep change flip is only flipping upside down, not flipping the sign. All right, so let's try to apply this division property again. So here's a division equation, but we're going to apply the multiplication property of equality. So again, using that rule 2 from those rules I gave you at the beginning, let's clear the fraction. Let's multiply both sides by 3 to clear the fraction. And now I'm just left with m equals negative 15. Now again, you could also say what I did really was apply the multiplication property of equality, because what I did was I multiplied the left and the right side by the same number. Again, remember, on all of these problems, you can apply the check. So if I were to check this, my m over 3 equals negative 5. Take out the letter m, and then actually try to divide that, and it does give me negative 5 equaling negative 5. It checks. I did it correctly. Let's try example B. So on example B, notice I've got a mixed number. Remember, when you multiply and divide fractions, you need to make that mixed number improper. So that's my first step. I am going to make 6 and 1/4 improper by multiplying and then adding. So 4 times 6 is 24, plus 1 is 25. Now I have 1/4 s. First thing I'm going to do is try to get rid of those fractions. So I'm going to multiply both sides by 4. It clears the fraction on both sides. And now I'm left with 1s, or s equals 25. And again, you could also have thought about that as it's a multiplication equation. So to solve that, you would be dividing both sides by 1/4, which again means multiply by the reciprocal. So it's a little bit easier if you just use rule number 2 and clear the fraction. And again, we could do our check. We could take 1/4, multiply that by 25, and see if it equals 6 1/4. When I multiply 25 times 4, I get 25 over 4. And if you remember what you had here as an improper fraction, it's the same thing. So it checks. Yes?
Mrs. Corey, what did you say about...
So we're at the oral exercises. Let's try a couple. And then we're going to, I'll give you your assignment. For the homework, again, you're not doing the oral exercises. We're doing only written. And you're going to be doing 2 through 52 even. You don't need to do the problems, just the written exercises. So let's try a couple. All right, so for example, if we go up here to the oral exercises, and if I do number 3, I'll try 1 multiplication and I'll do 1 division. So here, it's a multiplication equation. So to solve this, I'm going to apply the division property of equality. I'm going to divide both sides by 3, and I get a equals -4. Let me try division problem. Let's try number 15 here. And I have -4 is equal to x over 3. Again, we are going to use the multiplication property of equality, which will also clear my fraction. And I get -12 equals x. Let me see if there's any negative variables. So like on number 16, it's a -11f equals -88. I'm dividing by -11, and a negative divided by a negative gives me a +8. Again, remember, you can always check. All right, so your homework again is going to be 2 through 52 even. Tomorrow we will cover 3-3, and we will also do the problem solving at the end of 3-1 and 3-2. So I'm going to modify your homework, what's on Canvas now. Right now, I'm going to take away the Monday homework since we didn't have school yesterday. And then tonight's homework is only the evens of the written exercises. Then tomorrow, your homework will be the 3-3 and the problem solving. So if you wanted to do the problem solving from 3-1 and 3-2, you can go ahead and do those. I'm going to assign the evens from those also. All right, so